Now let's find how we may implement the binary search tree. Eventually that's the goal, but between binary tree and binary search tree, the structures themselves are the same, but the data stored in those structures, the ordering is different. So let's take a look at how we may implement a binary tree. So in binary tree or binary search tree, the very basic idea is that we have a node there, and then we store data here, and that it may have a left subtree and right subtree. So we store data here, and then in right subtree we may store data here, and that it may have a no left subtree of 10, but it may have some data on the right subtree. So eventually, the very last node in the structure, there will be no left and no right, and so on. So that's what we expect as a result of a binary tree or binary search tree. Then to realize this kind of structure, we see that we need some node structure. So here, consider a node structure where one member is to store data. So you have a 20, 10, and so on. So data is stored. And each node has a left subtree and right subtree. So it should have two members. One is a pointer to the left node. So this one is a node structure as well. This one is a node structure as well. So here, data 20 is stored, but here data 10 is stored. Here data 30 is stored. Then for 20, the left subtree, this member should be a pointer, so it points to this node. This one points to the right side. Then for 10, it has two members again, and the left pointer is a null. The right pointer, you have another node which has a data 15. Data 15 node, left one is null and right one is a null as well. So we need to define a structure to represent each node. So each node should have a minimum three members: a data member, the left pointer, and right pointer. So let's define a class called node to represent this structure. Node.h, the interface, pragma once. So class node, we want to define that. And for illustration purpose, let me define all public member first. Eventually, we will change it back to private later. So for this implementation, let's assume the data type is integer only as a data. So we have learned how to convert this one a template class. So later we can convert it to, for any data type, a template class. But at this moment, let's just choose a integer type only. And then it will have a pointer to the left subtree or left node, and pointer to the right node. So that's the basic structure of the node we are going to use to implement some structure. Then let's define implementation of that. So include node interface, and then node constructor. In the constructor, we specify data directly there, and the data member is initialized as the one provided in the left, null as a initial value, right null is going to be the initial value. So that's implementation of a node structure. And node.h, let's give a constructor which takes the data directly there. So using that, let's try to let's try to have an idea how we may implement a binary search tree. So here, if I create now, so here let me include the nodes class we have just defined. So here, if we create a node, N1 new node with the data 10. Then what we get inside the computer memory is the node with the data 10 is just created. The left member, right member, those are null at this moment. That's how we define the node class there. Of course, the address of this one is stored in pointer variable n1. So this variable n1 is pointing to the node structure just created. That's the picture. Now we want to add a left node. Suppose we want to add a left node such that, so here on the left of the node, so let's store data 5. Then this pointer should point to new one just created, and then left null, right null, something like that. So to make this happen, what you could do is that n1 left, now let's just create node with a 5. Then this picture is realized. And the right of a node 10, let's store data 15. Then we could do right. Currently it's null. Now allocate the node with the data 15. Then what you get out of this third statement is that now on the right we create a node, data 15 is stored, left and right those are null by the construct of the node class. Now this one pointing to the one just created. So in this picture, what we get in simplified graphical notation is that we have a 10 node, which is root of the binary tree. In the left, we have a 5. Right, we have a 15. So that's the one. And then the N1 is pointing to the root of the entire tree. So we may call this one as a root pointer node, like that. And that may more readable name for that. So here we may change that n1 to a root pointer and the like. Then in this, let's add another node to the structure. So here we are going to add a 20 here. Then what you need to do is allocate a node with the data 20. When it's created, left is null, right is null. Now this link should point to the new one just created. So to do so in the program, what you need to do is root pointer to the right is pointing to root node 15. And then from there, if you do right, then we are referring to this one. So right member of 15, where we allocate the node with the 20 data 20. So that's how we keep adding node to the binary tree. So that's the idea. So in ultimate implementation, we are going to have this one, root p, as a part of the binary search tree variable. If I have a binary search tree b, then variable b will have a pointer to the root of the node, which represent the binary search tree. And then as we add or insert into the binary search tree as new data, new data, new data, we are going to wrap it by node structure and then arrange links, something like this one. So those parts will be created dynamically as we do operation for the binary search tree. For example, insert. As we do insert, 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 and the node will be created and the links will be organized as such. So binary search tree itself will have only one pointer, and then node structures will be created as we do some add operation onto the binary search tree.